Hey everybody, this is Mr. Beckstrom, and today we're going to go over the SLO quiz. Hopefully we'll get it done in 15 minutes. If not, I'll do a second video. But for the first question here, we want to take this equation and we want to put this uh, in the quadratic, in the vertex form. And the vertex form looks like this. It's y equals a times x minus h quantity squared plus k. So really we're going to have to do a complete the square on this in order to make this work. So let's do it over here. So the first thing I always want to do is if there is a coefficient number in front of the x squared term, I want to factor it out of the first two terms here. So this would be factor that 2 out, and then you'd get x squared, and then negative 8 divided by 2 is negative 4, so that's minus 4x. Plus 6. We'll just leave the last term alone outside of the parentheses. So we have this. Now the reason we do that is so we can complete the square. So what we're going to do is we're going to add and subtract a number, the same number, and but we need a specific number by doing this calculation. What we're going to do is we're going to take the value that's in front of the x term once we factor that 2 out, and in this case it's a negative 4. We divide it by 2. And then we square it. So negative 4 divided by 2 is negative 2, and negative 2 squared is 4. So that's the number that we're going to need to add and subtract here. If the number was, for example, 8, you would divide it in 2, which is 4, and then you would square it, which is 16. So you just have to take that number in front of the x term, divide it by 2, and then square it. So for us, we need a 4 in order to complete the square. So that's minus 4x. Plus 4, that's the number we need, but we have to subtract a 4 so we don't actually change any values of the variables, and we get something like this. Now the only one that we need here is the plus 4, so I want to take the negative 4 and bring it outside of the parentheses, and in order to do that I need to distribute it with the 2 on the outside here. So negative 4 times 2 is negative 8, so I can take a negative 8 and pull it out here and get rid of that negative 4. So this is going to be 2x squared minus 4x plus 4. And then this is going to be plus 6 minus 8. Remember, we have that minus 8 because we had to distribute the negative 4 with the 2 to pull it out. Now this is in the squared form here, so I can actually write this as x minus 2. It's going to be that first number I got when I divided the x term by 2, that negative 2. So I can write that as x minus 2 quantity squared. Notice that this thing here is equal to this thing here. We just wrote it as a binomial squared by finding that special value there. And then this is going to be minus 2. So now we are in this form here. That means my a is equal to 2. My h has a minus sign here in the formula, so that means we're going to have to take the opposite of whatever's in the actual equation. So my h is going to be a positive 2 because that's a minus 2 there, and then whatever value this is over here. So my k is going to equal to negative 2. So my vertex is going to be, the x value is going to be a positive 2, and the y value is going to be a negative 2. And then if I want to go ahead and graph this in my math lab here, I'm going to select the parabola button here. And then my first point I'm going to do is the vertex here at 2, negative 2. I'll put a point there. And then I just have to put one other point. I can choose any x value I want other than 2 in order to do this. So let's take an easy one. Let's take 0. So if we took 0, that's going to be 0 minus 0, which is 0 plus 6. So 0, 6 is also a point on this parabola. So for my second point, I would go to 0, 6, and plug that point in, and then it'll do my upward opening parabola there. All right, let's move on to the next one. Okay, so for this next one here, we're going to look at this function here. F of x is equal to 1 divided by x plus 3. We want to find all the asymptotes, x-intercepts, y-intercepts for the graph, and we want to sketch it. So in order to sketch it, I'm going to go over to my calculator, go to y equals, and put that function in there. It's going to be 1 divided by, don't forget to put the whole denominator in parentheses, x plus 3, and graph that, and it's going to look like this right here. So it looks like the x-axis is a horizontal asymptote. It looks like we have a vertical asymptote here at x equals -3. And let's kind of answer these questions. So the first one is going to want us to sketch it. So I'm going to look for the sketch that looks just like this here in the answers. And the second thing it says is find the vertical asymptote. So the vertical asymptotes is where this function is going to be undefined. So we can find that by just setting the denominator equal to 0. So x plus 3, that's because we cannot have a 0 in the denominator. So if I find out what values make the denominator equal to 0, that's going to be where the vertical asymptote is going to be. So x is equal to -3 after we subtract 3 from both sides. So that is our vertical asymptote. For our horizontal asymptote, we're going to see what happens when x gets larger and larger and larger, or smaller and smaller and smaller. And in both cases, the numerator is staying the same, but the denominator is getting bigger and bigger and bigger, or smaller and smaller and smaller, and this value is approaching 0. Now another way to look at this is if the variable in the bottom has a higher exponent than the one in the top, which the one down here has a 1 and the one up here has a 0, then this function has a horizontal asymptote at y equals 0. So that would be our y equals 0 is going to be our horizontal asymptote. That's the horizontal line where this function approaches. All right, and then for the x-intercepts, that's going to be where y is equal to 0. And so if I set up an equation 1 over x plus 3 is equal to 0, the only way I'm going to get a 0 here is if I have a 0 on the top and a non-zero on the bottom. But there's no way I can get a 0 on the top here because it's already a 1. So there's not going to be any x-intercepts, and we can verify that by looking at our calculator here and seeing that it looks like it approaches the x-axis but doesn't actually ever touch it. So no x-intercepts there. And then finally the y-intercept, I'm going to let my x's equal 0. So y is equal to 1 over 0 plus 3. So that's 1 over 3. So that's my y value. So I'm going to have a y-intercept at 0, 1/3. All right, let's go ahead and take a look at the next one here. All right, so for this next one here, I have 3/4 raised to the x is equal to 64 over 27. Now we've learned a process of solving this by taking either the log or the natural log of both sides and then bringing the exponent out and then dividing. And you can do that in this case, but there's also, you can do this algebraically as well. Notice that 3 cubed is 27, which is down here, and 4 cubed is 64, which is up here. So the only problem is that this one's on the top and that one's on the bottom. And the idea here is if I can make the base, remember this is really raised to a 1 right now, if I can make the base the same on both sides, then that means that the exponents have to be equal to each other. So I'm going to work on making this base equal to that. So let's kind of work on this part here. So the first thing I want to do is I want to get the 27 on top and the 64 on the bottom. And I can actually do that just by, so 27 on top and 64 on the bottom. I can really just do that by changing my exponent from positive to negative here. That actually flips it. And if you want to verify that for yourself, just go over here and write 1 over 27 over 64. And remember, you're going to multiply the numerator by the reciprocal of the denominator, so you should get that back if you do that exercise. Now that I have the 3 cubed on the top and the 4 cubed on the bottom. I'm going to write that as 3 cubed here and 4 cubed down here, just like so. Now, if I'm taking the power to both of those, really, I can just factor both of those out. So that's going to be 3/4 raised to the third. I just pulled that 3 out of, if it's the same exponent on the top and the bottom, I can pull it out and apply it to the fraction like this. And then this thing is still raised to the -1 power. So I just rewrote this as this and then kept the -1. And finally, if we take an exponent to an exponent, I can just multiply those together. So now I'm going to get 3/4 of the x is equal to 3/4 of the -3. Since the bases are the same, I can just set those exponents equal to each other. So x is equal to -3. All right, let's take a look at the next one here. Okay, so here they want us to use transformations to the graph to graph the following function here and state the domain and the range. So we have this function here, y is equal to x plus 2 quantity squared minus 4. Now the way we're going to do this is I'm first going to take a look at, let me make that a different color here. I'm going to take a look at the function y is just equal to x squared, and I'm going to graph that. So that has a vertex at the origin, and it goes upwards, something like this. Oops, let me get that other side a little bit better there. Right, it's symmetric on both sides of the y-axis, and looking good. Now let's see what these, the plus 2 and the minus 4 does to this function. So the plus 2 is actually going to move this to the left by 2 units. So we're going to go 2 units to the left. And the minus 4 actually moves it 4 units down. 4 units down. Make that a little bit better there. Now, if it's a plus here, it moves it to the left. If it's a minus, it moves it to the right. And that's because of the formula. The formula has a minus there. So it's kind of the opposite direction that you would think. The -4 here, that actually moves it down. If it was a plus 4, it would move it up. So now we're going to have a parabola here, and its vertex is going to be at -2, 4. And this is going to be going upwards here. So when we graph this using the graphing tool there, again, we're going to choose the parabola there. And then we're going to put our first point at -2, 4. And again, we can just take any point that we want to for x and see what our y is. So let's take the easy one, 0. If I put a 0 in here, I'm going to get a 2 squared, which is 4, and a 4 minus 4 is 0. So I'll actually get the point 0, 0. So after choosing the parabola, I'm going to put a point at -2, 4, and then I'm going to put a point at 0, 0, and that's it. All right, guys, I'm going to do the last question in a different video. All right.